Hello friends, our today's point is triangular factors. Friends, in this point we will see how to factorize matrix A, for example, into lower triangular and upper triangular matrices. Okay, here the lower triangular matrix, if you don't know, lower triangular matrix is a matrix whose elements below the, okay, suppose this is a matrix. Okay, this one is a diagonal of the matrix. Okay, and elements above the diagonal, for example here, all are 0. Okay, those matrices are lower triangular matrix. Okay, and U stands for upper triangular matrix. Okay, friends, those are the matrices whose elements below the diagonal are going to be 0. Okay, like this. I think this is clear for you what is meaning of lower and upper triangular matrices. Also friends, we will see how to factorize A, matrix A, into lower diagonal and upper triangular matrices. Friends, if you see, only difference is the D is in between L and U. Okay, this U and this U is not same. Okay, this, but the L here and L here is the same. This du, term du, is derived from this u. Okay, means suppose I will name it as u1. Okay, then this one is u2. Okay, how can we, means we have to just convert u1 into d u2. How to convert this I will show you in with the example. Okay friends, I think we have to start. I will start with the example. First I will clear this. I have already solved or written one example. I will open that. Friends, please don't get confused with that much writing. I will explain each one by one. Okay, please look at here. I have written just a simple example. Okay, this is a matrix A, X equal to B. That much simple is this. Okay, now I want to solve this matrix. Okay, to find out the UVW. In general, what we will do, we will convert first this matrix into upper triangular matrix. Okay, this matrix A into upper triangular matrix. For that we have to convert, just a second, we have to make 0 at this position, then at this position, finally at this position. Okay, I have written few steps to do. Okay, to make 0 at those position. These are the steps written in green marker. Okay, see, to make 0 here, we will subtract 2 times row 1 from row 2. Okay, we will get 0. Then next step will be to make 0 at this point. Okay, at this point, see here, to make 0 at this point, we will subtract minus 1 times row 1 from row 2 simply. And third step we will see later. Now I have recorded those steps. Instead of directly subtracting rows, what I did, I have recorded these steps into matrix form. See, G, F, E. Okay, these are the matrices. This one is G, this one is F, this one is E. Okay, I have written one matrix for each steps. Okay, step 1. Okay, this, just a second, this one is step 1, this one is for step 2, this one is for step 3. Friends, if you don't know how I have converted those steps into matrix, you can see my previous video on the elementary matrices. Okay, I will explain this in short. For brief, you can refer previous video. Okay, See, if I have just written a minus 2, okay, here, if here will be 0 for example, then this matrix is look like identity matrix. Just I have written here minus 2. Okay, just a second, I will show you. This 1 1 1, okay, this is a simple matrix, okay, identity matrix. But to record step 1 into this matrix, I am subtracting 2 times, that's why I will write minus 2. But at what position? At the position where we want 0 here, means that's why I have written here minus 2. Okay, I will write neatly. That much simple is this. Now next step is subtract minus 1 times row 1 from row 3. Same here, we are subtracting minus 1 times, that's why minus minus will get plus, and here will be our 1. Why here? Because we want 0 here. Similarly for step 3, we are subtracting minus 1 times, okay, that's why minus minus will get plus, and we want 0 at the same position. Okay, that's why I have written here. That much simple is this. Okay, I think you understood. Now next step is, we have two options. You can multiply this matrix C to A, you will get 0 at here. Then the resultant matrix will get multiplied by this F, you will get 0 at this point. Then resultant matrix will get multiplied by G, you will get 0 at this position. Okay, like this. Or you can multiply all of these elementary matrix at a time, G, F, E, and the resultant matrix, this one, okay, this one can be, just a second, can be multiplied to A. Okay, and your matrix will get directly converted to upper triangular matrix. See, this is a upper triangular matrix. Okay, what I multiplied all the elementary matrices at a time, okay, G, F, E, like this, to A, and I got upper triangular matrix. That much simple is this. Friend, this is a lower triangular matrix, but it is not L. Okay, this is not L. Note that, please. L is different. I will show you. Now I will open next part. Friends, we will come again to this example because we have found it just one part, which is U. We have to find out L. Okay, but before that, why A is equal to L into U? See here, what we did, we have multiplied GFE to the A, we got U. Okay, now what is our next step is, if you take inverse and multiply both the side, okay, GFE whole inverse multiplied both the side, you will get this. See here, equal to GFE whole inverse U. Now we have U. I have given name to this GFE whole inverse L. Okay, now we have L into U. Now you know what is L. L is simply GFE whole inverse. Okay, now friends, I will split this GFE whole inverse into single, E inverse, F inverse, G inverse. Okay, to the proof of this I will show you in next videos. Okay, how GFE whole inverse is equal to inverse F inverse G inverse. Okay, I will show in the next videos, but for this video, remember this. Okay, now I think you get what is L. We have GFE. Okay, and we can find out inverses of those. I will show you how. Now look at right hand side. Simply at the right hand side, I will show you how to use LU to find out the X. or unknown. Our final aim is to finding out the x. Okay, here x. I will show you. Just a second. What I have written, simply x equal to b. Okay, equations into matrix form. Now we know a is lu, simple, but ux I have given one name c. Okay, c is a simple single column matrix which is a vector. You can call it as column vector. Okay, now that means LC equal to b, simply these two equations. Okay, now to find out the x, first we have to find out the c from equation 2. Okay, c is our unknown. Then we will put this c here in equation 2. We will find out the x. That much simple is this. Okay, please remember the proof of this, or these equations. These are the very important equation to find out the x. Okay, simple is this. Why ux equal to c? If you don't know, I will show you. This u is a matrix. Okay, 3 by 3, 4 by 4, any, but the x is a single vector. Okay, single column matrix which is column vector. When matrix is multiplied to the column vector, you will get again a vector. Okay, that's why. Okay, now you can find out the c, then put the c in equation 1, you will get x. I think this is clear for you. I will again open my previous example. Friends, please don't get confused. I will explain each one by one. Here our aim is to find out the L. Okay, we know L is equal to, look at here, just a second. L equal to GFE whole inverse. Okay, and which is E inverse, F inverse, G inverse. Now we have to individually find out. We can directly find out from this product, or you can individually find out E inverse, F inverse, G inverse. See here, I have written what we have, GFE. Look at here how I find it out. E inverse from E. What is difference between these two, E and E inverse? Just I have reversed the sign. Okay, of this element -2, I have written only 2. Okay, reverse the sign. Friends, this method is not applicable to in general matrices. Okay, this is applicable only for this type of matrices. Okay, just reverse the sign of this one to find out the F inverse. Similarly for G inverse, reverse the sign of this. Just a second. Okay, just reverse the sign of this. Okay, here is a 1, here is our -1. That much simple is this. Now you can multiply to find out the L inverse, GFE whole inverse. Now friend, if you see this is a lower triangular matrix, we will give name L. Please note that all of the elements below the diagonal are our multiplier. Okay, during the elimination I have shown you that few steps to find out the upper triangular matrix, and the multiplier was written here. Okay, I think this is clear for you. Now we have both, we have L, we have U. Okay, and we will find out the X. Now we don't need to save. See here what we have A, we have L, we have U, and we have B. Okay, that much information we have. Simply our equation 2, this one is our equation 1. We'll first find out C. Okay, just write down as usual, C, C1, C2, C3, L, B. If you see, you will directly get C1 is equal to 5, and you can forward substitute to find out this C2, C3. Okay, I think you know how can we do forward substitution? Okay, now ux equal, now we have c, just put c here, 5 minus 12 to ux equal to c. Now here, if you see from the last row, you will get w equal to 2, and you can backward substitute, okay, like this, to find out the remaining two unknown uvw. That much simple is this. This is x, this is c. Okay, I think you understood how to find out x from by factorizing a in the form of lu. Okay, now please friends, remember, I will move how to factorize a into ldu, but before that, look at u here. If you see, the diagonal elements of u are not ones, all of are different. Okay, 2 minus 8 1, but not all are 1. Okay, in ldu, see, in ldu our u will have all of the diagonal elements are going to be 1. Okay, I will show you. Just I have to first clear this. Okay, I will open new. A equal to l d u. Okay, I will directly show you how to convert. Just take a simple example. Consider A equal to, we have one matrix 1 2 3 4. I will give you L in U of this matrix 1 3, just a second, 1 0 2 minus 2. Okay, this is L. Now U is 1 2 0 minus 2. Okay, this is U, L U. Now to find out LDU, we have to first find out LU, which we have. Okay, now L is the same. Okay, just I want more space. Just a second. L is the same, 1 3 1 0. Now D is a diagonal matrix. Okay, just write down diagonal of the U. Okay, and diagonal matrix is a matrix whose diagonal elements are non-zero, or you can say diagonal matrix is a matrix whose all of the elements are zero excepting its diagonal elements. Okay, now we have to find out u. Just a second, or new u. To find out the new u, just divide the first row of previous u by its diagonal elements. See, 1 by 1 is 1, 2 by 1 is 2. Now move to the second row. Okay, or its diagonal elements is minus 2, so divide it with minus 2, you will get 1. Okay, that much simple is this. Means I think you understood. If you don't know, I will explain again. See here, we have previous u, just I will give name u1. Okay, u1 is a matrix. Okay, suppose its diagonal elements will be d1 d2 d3. Okay, and u a1 a2 like this. Okay, a3 Now I have to convert this u into du. See, du. Just a second. D is d1, d2, d3, and u will be, see, d1. Just a second. To find out the new u, just divide row 1 by its diagonal elements. Means here will be 1, a1 by d1, a2 by d2, like this. And move to the second row. You divide with d2, you will get 1 u3 by d2, like this. Now for d3, I think you understood how to convert u1 into du. Okay, that's it for today's point. We will see you in our next point. Thank you. Hello friends, our today's point is triangular factors. Friends, in this point we will see how to factorize matrix A, for example, into lower triangular and upper triangular matrices. Okay, here the lower triangular matrix, if you don't know, lower triangular matrix is a matrix whose elements below the, okay, suppose this is a matrix. Okay, this one is a diagonal of the matrix. Okay, and elements above the diagonal, for example,